Questions 21 to 25 on the 2004 Grade 8 Gauss Math Contest. On Tony's map, the distance from St. John, New Brunswick to St. John's, Newfoundland is 21 centimeters. The actual distance between these two cities is 1050 kilometers. What is the scale of Tony's map? So 21 centimeters over 1050 kilometers. Now, we've got to get this into the same units, right? So that means I've got to convert 1050 kilometers to centimeters. So I'll do it in two steps. First, I'll convert it to meters. And how do I do that? How many meters are there in a kilometer? 1,000. So I multiply this by 1,000. And if you do that, you'll get 1,050,000 like that. And that's the number of meters. Now I have to convert this to centimeters. And how do I do that? I'll multiply by 100 because there's 100 centimeters in a meter. So if you multiply this number by 100, you get 105 million centimeters. And now, since we have the same units, we can go back and plug that in. So 21 centimeters to 105 million centimeters. And what that basically means is that if on this map something is 21 centimeters apart, in real life it's 105 million centimeters. So we've got to convert this now to lowest terms. If you divide top and bottom by 21, you get 1 on the top. And the bottom, 105 million divided by 21, is 5 million. Therefore, the answer to number 21, they've written it in a slightly different format. They've written it as 1 colon 5 million, same thing. And that's choice E. Water is poured from a full 1.5 liter bottle into an empty glass until both the glass and the bottle are 3/4 full. What is the volume of the glass? So you have initially this big bottle, and you are going to pour some of the water into a glass. And when you do that, the water will essentially comprise 3/4 of the glass. All right? And initially, this glass, they're saying, is empty. But they're saying that the bottle initially is full. Okay? So what I'm going to do is just break this up into components. The first is this part here, I'll call X. This part here, I'll call Y. All right? Now what they are doing is they're taking X and they're pouring it into the glass. All right? And when you do that, this X represents 3/4 of the glass. So we're going to have to create a few equations and then solve those equations. And then they tell us that this bottle, the total is 1.5 in terms of its volume. So in terms of a formula, that basically means that X plus Y is equal to 1.5. Correct? And we also know that Y, this one here, represents 3/4 of 1.5. And entirely based on what the information they give us in the question. Right? So there you go. I think we can solve this now. So the first one, Y is equal to 3/4 times 1.5, will give me, let's see, 3 times 1.5 is 4.5. And 4.5 divided by 4, 1.125. Okay? Now we can plug that value of Y back into here and get a value for X. So if we do, we get X is equal to 1.5 minus Y. And since y is 1.125, we put that in there, and therefore x, in terms of a numerical value, is equal to 0.375. And then now that we have x, we can figure out the glass, the volume of the glass. 0.375 is equal to 3/4 of the glass. So that means 4 times 0.375 divided by 3 is the glass. And if you do the math, 4 times 0.375 and divided by 3 is 0.5. And liters is our unit. So the glass is 0.5 liters in terms of its full volume. So number 22, the answer is A. In the diagram, the value of x is. So in this diagram, we have to start labeling as much as we can. And this is 30, right? So this will be 180 minus 30 because the angles about a line are always equal to 180 when you add them up. So this has got to be 150. And then this line means that those two are the same. And this means that those two are the same. So this and this, if you add them, is the same as this and this. So that means, in a very interesting way, that AC, the length from A to C, is the same as the length from A to B. So that is an isosceles triangle. And because it's an isosceles triangle, these two angles are the same. So if that's 80, this has to be 80 as well. So now we've got this shape here, this four-sided shape, and we have all the angles listed. And the sum of the angles add up to, well, it's two triangles, so 360. So we'll do the math. 80 plus 150 plus x is 360. So if you solve this, you will get x is equal to 50. And therefore, number 23, the answer is C. Let x be the 3-digit number with digits ABC, and y be the 3-digit number with digits CBA. The digits A and C are not 0. If x minus y is 495, how many possibilities are there for x? So A, B, C is x, and CBA is y. Now, how is this of any use to me? Well, I'll show you. Let's say ABC was some number, right? Let's say it's 542. What is 542? It's actually just 5 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 2 times 10 to the power of 0, correct? 5 times 10 to the power of 2 is 100, right? So it's 5 times 100 plus 4 times 10 plus 2 times 1, because 10 to the power of 0 is 1. So this is 500 plus 40 plus 2, which is 542. All right? Now, I showed you that for a reason, because that is the form in which I have to write each of these for this to make any sense. So ABC, therefore, is 100 times A plus 10B plus C. Okay, exactly the way I did that right there for 542. And in a very similar way, y is going to be 100C plus 10B plus A, like that. Okay? So that's the first part of the question. Now this is a very important clue that they gave you. X minus y is equal to 495. Okay? Now that's very important, because that's going to help us basically solve and give us a hint or a path to understand how many possible values of x we can get. So if x minus y is 495, let's plug in this and this into this equation. So x is 10a plus 10b plus c. Y is 100C plus 10B plus A, and that's 495. Okay, so let's do the math. We got 100A minus A, that's 99A. 10B minus 10B, well, that's 0, so the B's actually disappear. And then the C minus 100C is 99C negative, so that's 495. Factor out a 99, you'll get A minus C is 495. And then A minus C is 495 divided by 99, which is just 5. So there you go. We've narrowed it down to a very helpful final solution. Now we can figure out how many different possible values of x I can get, because I believe that's what they want us to figure out. How many possibilities are there for x? Okay. Well, A minus C has to be equal to 5. So I'll make a little table here, A, B, and C, because x is basically equal to A, B, C in terms of those digits. So let's make a little table, but the good news is that the B cancels, so the B can be anything. So I don't even need to include B in my table. Just A and C, these are the digits that the condition is for. Okay, no problem. Let's start. So A is a digit, right? It's between 1 and 9. It cannot be 0. That was told in the question. A is not 0. If you don't remember, it's right here. A and C are not 0. So any digit between 1 and 9. So let's start with 9, and let's see what we get for C. If A minus C is equal to 5, then that means if A is 9, C's got to be 4. And in a very similar way, if A is 8, C is 3. If A is 7, C is 2. If A is 6, C is 1. Now if A is 5, C would have to be 0, and that's not possible, right? Because C is not 0. It tells you that in the question stem. And if A is 4, you start getting negative values for C, and you can't have negative values for a digit, right? So there you go. These are the only possibilities. So x can be 9 for A, some value for B, and 4 for C. But that's not a number. I've got to put in a number for B. B can be anything from 0 to 9. So I can have 904, 914, and so on, all the way down to 994. How many did I make here? Well, I made 10. Correct? So that takes care of that one. And in a very similar way, you can do the same thing for 8 and 3. 8, some value for B and 3. Well, B can be anywhere from 0 till 9, 8, 9, 3. How many did I get there? I got 10. So I got 10 for this scenario, 10 for that scenario, and in a very similar way, you get 10 for these two. So the total possible is, add up these, and that is 40. 40 possible values of x. And therefore, number 24, the answer is B. A large block, which has dimensions n by 11 by 10, is made up of a number of unit cubes and one 2 by 1 by 1 block. There are exactly 2,362 positions in which the 2 by 1 block can be placed. What is the value of n? So first, let's draw a diagram, and let's label this. So I'll label this side 11, and this side 10, and this side n. Now these gaps is because we don't know, right? How big is n? So that's why I wrote ... and I left little gaps there to kind of illustrate that. Okay, so let's work with this. Now there's a few scenarios, right? The first scenario, of course, is when you're placing this block up here. So I'll just start here. And these are unit cubes, so we can just place the block like this. Okay? So in the first scenario, we have to figure out, how do I place this block here, this guy right here? This is at the heart of the question. Okay, I can place it like this. One position there, right? Two position, and so on. Third position, fourth position. Well, you get the idea. And if I do, how many such positions can I put it in? Remember, it's a block, it's not a line, so it's got to cover all the way till there. All right, so it's a little bit of a conceptual challenge, I think. If this is my block, it's going to be kind of like that, right? So very quickly you can figure out that if you make a table, and my first scenario is the horizontal placing, that I'm going to be able to do that all down the rows, 1, 2, all the way down to the nth row. All right, and in the first row I can put it in 10 positions. It can go here, that's the first position, second position, and if you count all the way down, you'll get to 10 positions. All right, so 10 ways of putting that horizontal block. Putting that block horizontally, better way of saying that. So in row 1, there's 10 ways, row 2, there's 10 ways, all the way down to the nth row, 10 ways. So the total is 10n. All right? Now, keep in mind, that only takes care of one slab of this big block, I guess, this big shape. We have to do this for that slab, for that slab, for that slab, right? And how many slabs would there be? There'll be 10 of them. Right there, it's 10, right? And each slab has a length of 1 because they're made up of unit cubes. So 10n only takes care of one slab, so all of the 10 slabs, it would be 10 times 10n. Okay? So I did that slowly to help you understand. Unfortunately, we're not done. We're not even close to being done. But I'm doing this so that you can understand this, doing it in a careful way. Now let's look at the vertical possibilities. And vertical meaning if we're going down like that way. Okay? Now we've got n of these, so I have no clue how far this goes down. So I'll just start putting in unit cubes like that. Now if I put the 2 by 1 by 1 block in a vertical position, it could probably go here. That's definitely one possibility. Correct? So basically like that. That's 1, 2, and 3, and so on, right? 4, 5, and so on. But the better question is, how many? Well, in the first column, column 1, n minus 1. N minus 1 times you can place that block. And that should make sense, right? Because when we did it for 11, it was 10. Column 2, exact same, n minus 1. How many columns do we have? We've got 11 columns in this scenario. So all the way down to column 11. Now let's add this up. 11, and each of them has n minus 1, so 11 times n minus 1. For that slab, only for that slab. Okay? But how many slabs are there? Well, there's 10, correct? So the total has got to be 10 times 11 times n minus 1. Okay? And I'll just simplify these. We can do that later, but just for the sake, 100n, and this is 110n minus 110. Okay? Now we have done two scenarios, and I'll label them. This is scenario 1, and this was scenario 2. How many more scenarios do we have? We have 4 additional scenarios. Okay? So it's a little bit of a challenge, but it's actually not so bad. The next one, I'm going to concentrate on this part of the diagram right here. Right here. Okay? Let's draw it in red just to show you that I'm doing it a little bit different here. this guy right here, just that slab right there. Okay, so here we go. Just drawing a couple more lines, just to, I think that should be enough. Don't want to make it too complicated. Okay, in that one, let's start with the horizontal direction first. In the horizontal direction, in a very similar way to what we did previously, we got row 1, row 2, all the way down to the nth row. And in each, how many ways can I place the block? Well, let's see. I could place it like here, one way, right? I'm going horizontally, 2 ways, right? And so on down. And because the length is 10, 9 ways of doing that for each row. Okay? So that means that the total for this particular scenario is 9 times n. But we have to do that for all the slabs, all of these guys. And if you do that, you have to multiply by which number? 11, correct? So this total becomes 11 times 9 times n. And that is, of course, just 99n. So this one I'll call scenario 3. So far, so good? No problems? You understand it? Let's go with vertical. This guy right here, that slab, but now going up and down. In a very similar way to what I did over there, we now have to look at the columns. So column 1, column 2, dot, 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 until how many columns? 10 this time, right? Because the dimension is 10. And each column, how many times can I put that cube or that block? Well, I can put it like 1, 2, and so on, 3, all the way down to the bottom, and that would be how many? n minus 1. So n minus 1 here, n minus 1 here, and so on. So the total is 10 times n minus 1 this time. But that only takes care of one slab, so I've got to figure it out for all the slabs, and there's 11 of those. So this is 11 times 10 times n minus 1. And I'll call this scenario 4. Now here is where the question, the heart of the question in terms of getting the right answer, I guess. This scenario that I just did, 4, I've already done previously. So I don't need to count that because I've already counted it. Which one of the previous 3 is it? You can figure that out conceptually, visually. Or the beauty of this question is you can figure it out mathematically. It'll have the exact same value. So which one has the exact same value? Even if it's in terms of n. Which one has the exact same value as number 4? Is it scenario 1, scenario 2, or scenario 3? It is scenario 2. Right here. This is the same as 4. So same as 4. So that one does not need to be counted. So I'll just put already counted in the text right there. All right, we've got only 2 more scenarios and we can solve this question. The next one is this guy right here, up at the top, right here. So I'm going to put those in green to let you know that it's a slightly different part of the diagram. Okay, so far you're an expert now, I think. Horizontal and vertical. So in the vertical, well, first of all, I have to tell you which one is horizontal. I'm going to call these guys horizontal. If you're going from there to there, and it doesn't really look horizontal, but if you flipped it, I guess it would be. Horizontally, first of all, how many rows? Row 1, 2, all the way down to 11. Okay? So there's 11 rows this time. dot, 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 all the way till 11. And in each row, how many times can I put the block? Well, 1, 2, and so on, right? But the dimension there is 10, so that's going to be 9 times that I can put it. 9, 9, all the way down till 9. So the total here is actually 9 times 11. But as always, we have to consider the fact that that's only one slab, and there's a bunch of other slabs going down, right? And how many slabs do we have in this orientation? N. So this total is N times 9 times 11. All right? And I'll call that scenario 5, like this. Now scenario 5, guess what? It's already been counted. Now you tell me which one of those first 4 is the same as scenario 5. I'll give you a hint. It has the same numerical value. It's this one right here, scenario 3. Even if you're having a difficult time conceptually, mathematically it's right there in front of you. That was basically 99n. It's the same as 3. So same as 3, already counted. Okay? I'll put that in there, already counted. And therefore we only have one final scenario left, and that's the vertical one on this guy. So vertical, we're going to be looking at columns, and I have to be careful here. I have to tell you, this is vertical in this guy. All right. So, okay, no problem. Vertical in the columns. Column 1, 2, how many columns do we have in this case? We've got 10 columns this time. Okay, because this dimension is 10. And in each, you can put the block here, or you can put the block here, correct? And all the way down. So how many is that? It'll be 11 minus 1. So that's 10. So 10, 10, and 10. Like that. So the total will be 10 columns, and each you put 10, 10 times 10. And then, as always, you have to keep in mind that that's just for one slab. For all these slabs, since there's n of them, this dimension is n, this total will be n times 10 times 10. And this is the 6th scenario. Now what we have to do is add up the scenarios, except for the ones that we counted twice. So I'm going to include 1, I'm going to include 2, I'm going to include 3. 4 is already counted, so I can't include that. 5 is already counted, so don't need to include that. And 6 is not already counted, or is it? Right? It's a good question. Don't get it all, okay, I know the answer. Again, mathematically and conceptually, you should be able to see that 6 is the exact same as 1. So same as 1, and therefore already counted. Now, the reason I did it so thoroughly is because I want you to understand it. I don't want to say just, oh yeah, well, this scenario you don't need to do because it's already counted, and then move on. Because you might think, well, I don't understand that. Why is it already counted? So I have to show you, and not just in terms of a visual way, but also in a mathematical way. So 6, you also don't need to count. So the only ones you need to count are 1, which is 100n, 2, which is 110n minus 110, and 3, which is 99n. And these all equal what? They tell you, right? 2, 3, 6, 2. That is the number of positions. So 2, 3, 6, 2. All right, let's do this. So we got 100, 110, and 99. So that looks like 309n. And then 2362 plus 110. So this becomes 2472 is 309n. And n, 2472 divided by 309. And if this is not an integer, I give up. But fortunately it is. It is 8. So actually it's a little bit smaller than I had thought it was. No problem. Number 25 is 8, and therefore the answer is B.